Hey everyone, so I wanted to take some time to review a problem from your mastery check. So this is a similar problem. You can see that it's based on problem 4 from the dilutions mastery check. I've changed some of the numbers around. However, it's the exact same format. So I wanted to do this as an example for you all. All right, so I'm going to take you through my thought process for this. The first thing that comes to mind is what is this problem asking me? What type of problem is this? And so, well, first of all, I see it says how many moles are in 6.0 liters of solution that was made from 6.5 liters of a 14.3 molar solution. Well, in this case, the first thing, the simplest question is how many moles? That's just what I'm going to pull out right now. Open this up a little bit more. Something else, so that for that second question, what type of problem is this? Well, I see one solution. I see two solutions. So that tells me right away that it is some sort of dilution problem, which means that I need to use this equation. M1 V1, whoops, equals M2 V2. That is our dilutions equation. All right, so that's my first step. My next step, I want to go down here. Did I annotate everything? Ooh, good question. Well, let's look at the problem. What are we given? What is unknown? So I'm gonna highlight the unknown in red. How many moles? And then I'll highlight what we do know. Whoops, that changed on me. I have to do a new one. What we do know in green. We have a volume, we have 6 liters. We have another volume, 6.5 liters. And we have a molarity. So those are knowns because they have a number and a unit. In this instance, there is no chemical, but sometimes you will be presented with one. All right. Oops. So there, I have annotated everything. And I'm actually going to make a little note here so that I know what I know. Oops, let me back that up. I don't want it colored. Or actually, you know what, let's go for it. Colored, known equals, well, 6.0 liters, also 6.5 liters, and 14.3 molarity. And we'll get into how those fit into the equation in just a moment. What is unknown, so let me switch to red. Unknown is moles for one solution. All right, so now I need to figure out where these fit into this equation. So in order to do so, I'm going to look back to the original problem. It's asking me how many moles are in 6.0 liters of solution that was made from, and that's what I want to highlight. Let's see that in orange. Made from 6.5 liters of a 14.3 molar solution. So in this instance, that tells me when it says made from that these were my V1 and my M1. Over here, this is my V2, and so this must be part of my M2. And I say part of because this is asking for moles. I'm going to do this over here on the side. M equals molarity, which is moles per liter. So I just want to keep that in mind. That's going to be very fundamental to solving this problem. Alright, so now my next step is writing out my equation. And that's step number 3, setting up the problem correctly. So we know that we're going to be using this equation, M1V1 equals M2V2. We've identified what everything is, and so we need to set it up. I'm just going to use black here. So my M1 I already identified as 14.3 molar times my V1, which is 6.5 liters, and we set that equal to the second half of our equation. My M2, well, that's unknown, so I'm just going to leave that as the variable. And my V2, 6.0 liters, I will input there. So now I know I've set up the problem correctly. I've included all labels and everything. So now in order to solve for M2, I need to use my opposite operation of multiplication. I'm going to divide. So divide by 6 liters, and actually that's the whole side. And so I need to do that on both sides. 6.0 liters. Alright. I'm actually going to slide the screen this direction to continue with that. And so I now have 14.3, that's a 3 molar times 6.5 liters over 6.0 liters equals M excuse me equals M2. Jeez, it's a bad time for a series of sneezes. So there I am. Now, if I multiply the top (14.3) times 6.5, I get 92.95 over 6. And when I do that division, I get, I need to move my screen, 15.5 moles, or molarity, sorry. To be very specific there. You get a molarity of 15.5. Alright, but I'm going to zoom out and look at the whole thing. Maybe that's a little too far. Number 4, did I answer the problem? What is the problem asking me? Well, this problem, I'm just going to write this out in text. The problem is actually asking me how many moles. I'm going to capitalize that. How many moles? We found molarity, so not molarity, but how many moles? So my next step is to convert from molarity to moles. And I will actually write that. So I need to go from molarity, back that up, molarity to moles. So I'll clean that up for you all. So in another sense, I am going from moles per liter to just moles. Now, in order to do so, well, I'm going to take the starting quantity or the starting volume of this solution, which was 6. I had 6 liters. Actually, let me back that up. It was 6.0. Jeez. I don't know how the Khan Academy guy does it, but I'm trying my best. So I'm taking my starting volume of the solution because that's what I want to cancel out. I'm trying to cancel this out. And this is our conversion factor for molarity. And if I want to get rid of liters and go to moles, I need to cancel out liters. So just write that over 1 just to help me stay organized. Jeez. Okay. And so that means liters needs to be on the bottom. Molarity means, again, moles per liter. So how many moles per 1 liter did we calculate earlier? Well, we calculated 15.5. So now if I do my calculation, 6 times 15.5 equals 93 moles. Again, I want to highlight here, there is a difference between moles and molarity. Well, I hope that was helpful for you all. If you have questions after reviewing this video, please let me know. Oh, sorry, one last step. Did I label everything? Number, unit, chemical, is everything labeled properly? Well, I've got a number, I've got a unit, and just for this problem, there happen to be no chemical, and so we are good. We can just say moles of solute, because that is what was being dissolved in the solvent. All right. Please reach out if you have any questions.